Welcome to PhilotiMaths. In this video we're going to see how to find the inverse function of a quadratic function. Let's have a look at an example.
Welcome to PhilotiMaths, fighting problems one step at a time.
Okay, so in this example we've been asked to find the inverse function of f of x when f of x is equal to x squared plus 4x plus 3. Notice this is a quadratic expression, therefore we're looking for the inverse function of a quadratic. Okay, now this detail here of x being greater than or equal to minus 2, we're going to leave that there for now. We're going to touch on that a bit later in the solution of the exercise. Okay, lovely. As you may have seen in our previous video on finding the inverse function of a function, step 1 is to go ahead and replace this f of x with y. So we'll go ahead and rewrite it as y is equal to x squared plus 4x plus 3. Okay, now remember our goal here is to isolate x on one side and move everything else to the other side. Now whenever we've got quadratic expressions, in order to do that we have to complete the square. So for those of you who do not know how to complete the square, feel free to click on the link in the description below. We've created a video just on that. Okay, so now completing the square starts with spotting the number in front of x, which in this case is 4, and dividing it by 2. So we'll go ahead and write down 4 divided by 2. Well, that's simply equal to 2. Okay, so moving on now, we're ready to start completing the square here. So we'll just copy the y on the left, and then we've got equals. Now we'll have x plus this number 2 we just found, and this expression needs to be squared. And then we need to subtract this 2 which we have inside the brackets, but squared. Lovely, all we've got left to do here is to add this 3 in the end. So we'll just go ahead and add 3. Okay, so we've completed the square here now. We just need to simplify this expression as much as we can. So let's start by rewriting what we've got here on the left, which remains unchanged. So we'll have y is equal to x plus 2 squared. Now notice we have minus 2 squared. Well, 2 squared is simply equal to 4. Therefore here we'll have minus 4, and we'll just copy this plus 3 in the end. Okay, let's go ahead and simplify it for one more time. We'll just go ahead and rewrite this expression here. We've got y is equal to x plus 2 squared. Now next we've got minus 4 plus 3. Well, that's equal to minus 1. So we can go ahead and write down minus 1. Excellent. So now notice that we've got x plus 2 squared but minus 1 here on the right. So what we need to do is move this minus 1 to the other side. In order to do that, we'll just go ahead and add 1 to both sides. So what do we get on the left? We had y. If we add 1, we'll simply have y plus 1 on the left. Excellent. We'll just copy the equal now. Next we have to copy this expression here, so x plus 2 squared stays the same. And finally we've got minus 1 plus 1 which simply cancel each other out. Excellent, now we have reached a critical stage of this solution. We've got x plus 2 squared on this side, and we just want to get to x eventually. So in order to do that we have to get rid of this square from the right. In order to do that we just square root both sides effectively. But remember, whenever you square root both sides, you will need to put a plus minus here. So we've got plus minus, the square root of y plus 1, which is what we had on the left. And then we've got equals. Now on the right, because we've square rooted this expression, we simply have x plus 2. Okay, so now we've got one final step left in order to isolate this x on the right. And that is to move this plus 2 to the other side. Now in order to do that, we will simply subtract 2 from both sides. Okay, so let's see what we get if we do that, and I'll go ahead and continue up here. So on the left, we will simply have this minus 2, and then we have plus or minus this square root of y plus 1. And then we have equals, and here on the right we have x plus 2 minus 2. Well, plus 2 minus 2 simply cancel each other out, so we're just left with an x on the right. Excellent. So here what we are going to do is we're going to swap these two around because we like having x on the left. So if we just say that x is going to be equal to what we have on the left, we will have succeeded in writing it in a way which we prefer. So it's minus 2 plus minus the square root of y plus 1. Okay, so now notice we've got this detail up here, x is greater than or equal to minus 2, which we haven't looked at just yet. Now this is the time to do that. Notice we have x is equal to minus 2, and then we have plus or minus a square root, which is a positive expression. Well, let's think about this for a second. If x were minus 2 minus this square root, then it would be less than minus 2. But in this case, we need it to be greater than or equal to minus 2, therefore we can't have the minus, we need to keep the positive. And this is basically x. X is equal to minus 2 plus the square root of y plus 1. Therefore, this leads us to the final stage of this solution. Remember, the final step involves rewriting x as f minus 1 of x and rewriting y as x. So instead of x, we will have f minus 1 of x is equal to, and then we just copy this minus 2, and we have to add the square root of, and remember we swap this y with an x, and we'll just keep this plus 1 in the end. And this is our final answer. We've got that f minus 1 of x is equal to minus 2 plus the square root of x plus 1. Now, I'll very quickly show you a way to check whether this inverse function you have found is the correct one. And that will rely on the fact that f of f minus 1 of x needs to always be equal to x. So effectively, f and f minus 1 of x cancel each other out. Well, let's have a look at it. Now this was a short lesson on finding the inverse function of a quadratic function. If you enjoyed this video, feel free to leave us a like, subscribe to our channel for many more videos to come. See you next time.
Have you suffered from a maths-related injury in the last 4 months?
You're in the right channel. Welcome to PhilotiMaths!